Stairs and stair stringers specifically are one of the most challenging things to plan out as a carpenter. And in this video, I'm going to show you how to use SketchUp to create some temporary geometry that can be scaled to the exact finished dimensions that you need for the stairs. And then we'll work backwards from there, building the treads and the risers in order to arrive at the exact dimensions you need for the stringers. So let me show you exactly what I mean by some of the common mistakes that are made when planning out stairs. So one of the things you want to try to achieve when you're planning out stairs is you want to have each step the exact same size as each other. So you want equal steps, right? So a lot of people think that they want the stringer to basically be an equal cut, but the problem with that is once you add your treads, those dimensions actually grow at the bottom step and at the top step. So you actually have to account for the thickness of the treads specifically for the first step and sometimes for the last step. So in reality, you want to arrive at something like this where the finish surfaces of the stairs are actually at equal heights. So in order to do that, you actually have to subtract certain thicknesses from your stringer dimensions in order to arrive at the correct finish height. Now, it's totally possible to figure all this stuff out on your own. You know, when I used to do it in the field, I would kind of draw a mock-up of the finished stairs right on the board that I was going to be cutting the stringer out of. And that's really the best way to do it. That way you're visualizing everything accurately, but there's still a lot of opportunity to mess up. You know, in addition to just the tread thicknesses, you also have overhangs. You have to consider whether or not you're going to be adding a riser. A lot of times the rim joist of the deck itself acts as a riser. So you have to account for that. You know, you have to account for not adding a riser at that top step, which can sometimes trip you up as well. Now, I actually have a full written tutorial on this whole video that you can check out on my website. I'll have a link in the description below. But basically what we're going to do in this video is start out with a single step component and convert that into a group. And then you're going to scale that group down to the total rise that you need for your stairs and then get it aligned into position. And then you're just basically going to use that as a guide to draw your treads and risers. And then you'll be left with the exact dimensions you need to draw your stringers. So let's go ahead and get started. Hey, I'm Matt from MasterSketchup.com, author of SketchUp to Layout and co-author of SketchUp and Layout for Architecture. So let's go ahead and jump right in. You want to have your deck modeled already, and you want to have a ground plane in place. And the most important thing is to basically have the height of your deck positioned accurately to the total rise that you're trying to build these stairs to. So if you're actually measuring this in real life, you don't want to actually just measure straight down from the top of the deck. You want to project a level projection out from that top edge of the deck to roughly the distance, the depth of those stairs, and then measure the height down from there. And what that's going to do is that's just going to account for any slope that you have on the ground. So once you have that height established, you can go ahead and start creating the reference geometry for the stairs. So all we're going to do is grab the rectangle tool right here, or you can press R on your keyboard, and you want to just start drawing. It doesn't really matter exactly where, you just click once to start. And then you can add the left arrow key to lock the green axis or the right arrow key for the red axis, depending on which way you're oriented. And you can go ahead and just create a rectangle. And then we're going to just type in the dimensions directly after that. So for the dimensions of this step, it's not super critical because we're going to be scaling it. So we're going to actually type in the maximum height that we know we can go with. So there's, building codes that kind of establish this stuff. So we want to go a maximum of 7 3/4. So we will first define the width, which I'm gonna go with 11 inches and then type in comma, and then I'll type in that 7 3/4 and then press enter, and then it resizes to those dimensions. So once the rectangle is drawn, we'll just tap spacebar to get the select tool again, and we will double click on this face, and you can either right click, make component, or you can just tap G on your keyboard to create component as well. And you can create a name there if you want. I'm just gonna click create. And then the next thing we're gonna do is create an array copy of this step in order to figure out how many steps we need for this specific example. So with the step components still selected, we'll tap M for move, which is this tool right here. And we're gonna snap to this bottom front corner and click once to start. And then we'll tap Control on our keyboard to tell SketchUp that we wanna make a copy. And then from there, we can go and snap up to this corner here and click to finish. Now, we don't want to have to repeat that over and over. We can actually just type in 5x enter, and that'll make 5 copies of that component. So as you can see, I overestimated how many copies I needed, so I can actually type in 3x enter to correct that. Now, when you're making the copies of this step, you want to make sure you're overshooting the height, not undershooting it, because the height we established with the component is the maximum height. So we did that. That way we know that we're going to scale down. So you want to overshoot it and then scale down to it. So with these components copied, we're going to isolate them or contain them into their own group. And that's just going to make it easier to manipulate. And to do that, we're going to grab the spacebar select tool, and we'll click the first one, just a single click, and then we'll hold down Control and click the rest of these here. And then we can right click and make group. So now we have our basic geometry for the stair, but it's not accurate to the total rise that we need. So we just need to scale it. So by tapping S on the keyboard, it initiates the scale tool around the current selection that we have, and we can just grab this green scale handle and bring it down to reference something that's in plane with the height we want. So I know this corner is in plane with the top of the deck, so I can just click right there. I always like to find endpoints whenever I'm inferencing in SketchUp, just because I find that it's a much more reliable snap. There are face inferences where you could kind of just snap to the face, but sometimes SketchUp gets confused and might snap to something else unintentionally. So I just prefer to find endpoints to snap to. And so once we have this in place, now we can grab the move tool again with the letter M, and we can click on this point and just drag it back so it's in line with this front leading edge of the deck. So you'll notice that there's a slight overhang on the decking material, and that's intentional, and we want to make sure we are snapping to that front edge of the actual decking material. So we're going to account for overhangs and stuff once we start adding our treads and risers. Now, the other thing to note is we want to keep this top step in place for now. We're going to eventually delete it, but we're just going to use that for now as a reference to just double check everything and make sure our total rise is represented. In reality, the top step is really just the top of the deck. You're not actually going to be building a top step in this situation. And by the way, I'm using a deck for this example just because it's easier to visualize in this context. But really, you can do this for any type of stair in SketchUp, really complicated interior stair. This is a great way to work as well. Now, another thing is I'm not an expert in formulating the proper rise to run ratio for treads and risers. There's a lot of information about that online. I've got a few links in the description below if you want to learn more about that. There's usually like a sweet spot for calculating how deep you want your treads depending on how high the rise is. So, and again, this here would be your riser. The part you step on is called the tread, and the total rise is the distance from the ground, so to speak, up to the very top landing. So that's your total rise. And then your total run would be the distance from the front edge of your top step to the front edge of your bottom step. All right, so now we can start jumping inside of these reference components and start modeling the treads and the risers. So to do that, we're gonna double click with the select tool to enter this group. And then we're gonna double click again, because if you single click on any one of these, you can see it's a component. So we need to jump inside of that component by double clicking. And another thing I'm going to do is isolate this reference geometry into its own group. So I'll double click or triple click that. I will make group, and then I'm going to assign this to a layer, which I have a layer here already called dash that I created. If you don't have that, you can just click the plus sign, type in dash, and I'm going to assign that to the dash layer, and then I'll select a dash there. So now those edges will appear dashed. And the other thing I'm gonna do is just apply a color to this reference geometry and just set the opacity kind of low. That way it's easier for you to see. You don't have to do this, but I'm just doing that so it's a little bit easier. Okay, so to create the tread, I'm just gonna use this reference box with the rectangle tool. So tapping R for the rectangle tool, and I'll create this rectangle, and then I'll type in 3.5 inch, comma, 3/4 inch. Now notice how I use decimals and fractions. It doesn't matter. SketchUp will let you use any unit of measurement. And also notice how, since we're in a component, all of this work we're doing down here is being copied in all the other components. So that's why we used a component for that original step. So I'm just gonna use the push-pull tool with the letter P and extrude that, type in 4 feet, enter. And then I want to triple click this, right click, and make group. Now we could use a component for this because there are gonna be multiple copies, but we're gonna have to edit some of them anyway, so I'm just gonna use a group in this circumstance. And then to make the copies of the tread, we will grab the move tool with the letter M, and I'll click this corner here. I'll tap Control to initiate a copy, and then I'm gonna snap here, but we wanna make sure we have a small 1/8 inch gap in between the tread boards. So instead of 3.5 inches, I'm gonna type in 3 5/8, enter. And then I want a couple copies there, so I'll type in 3x, enter. And that gives us 4 copies of the tread. Now, don't worry that, this is a very small piece. We're gonna actually adjust that once we have the risers established and figured out. So just don't worry at this point. We're gonna adjust that later. Okay, so to create the riser, we will use the rectangle tool again. So R for rectangle, we'll click right there. We'll bring the rectangle down, and then we'll type in 3/4 inch, comma, and that's it. Because we snapped to the height, we don't need to actually type in the height. That's one of the reasons why we have this reference rectangle in the first place. And then we'll use the push-pull tool again with the letter P, and just extrude it out and snap to the other side. And then with the spacebar, which is the select tool, we will triple click this one, right click, and make group. All right, so we wanna make sure we have an overhang on the risers because we don't want the treads to be perfectly aligned with the risers. We want a slight overhang. So since we have a 1/2 inch overhang up here, we wanna copy that same overhang with the riser. So we'll just use the move tool with the letter M, and we'll snap and move it 1/2 inch. So we'll click again and then just type in 0.5 inch, enter, and that creates the 1/2 inch overhang. Now we might also want an overhang on the treads as well. So we could either push pull the riser in, or we could push pull the tread out. Let's go ahead and push pull the riser in. So double click to open the riser, tap P for the push pull, and we will click on this surface and I can snap right to 1/2 inch without having to type it in. And then on this side, I'm just gonna double click and that's gonna repeat that same offset. And you can see on this side, since we don't have that reference geometry in the way, we have a perfect overhang and on the front edge of the tread and on the risers as well. Now, if you've done everything right so far, you should also notice that everything is aligned on this side as well. So you want the front of the riser to be flush with this rim joist if you're not going to be adding, any type of riser to the rim joist itself. All right, so at this point you can jump outside of the component and we can delete this top step if we know that, everything's looking good there. And just so you can see, what we have here, we have each of these 3 steps as components, and inside each of those components, we have the reference square, we have each of the treads, and the riser. So all of these copies are exactly the same component. Now to fix this tread that's in the back, we just need to jump inside of this component and we can double click into that tread and adjust it. Now the other thing that you could do, which I actually probably would do in this situation, is equalize or center the treads. That way the front board and the back board are equally spaced or equally sized, instead of having this small sliver in the back here. Even though it's probably structurally fine, it just kind of looks, like a really small sliver there. So I would probably, take these groups and center them within the span of the tread itself and then make the adjustments there. Actually, let's go ahead and do that. So to actually find the center, I'm just gonna grab the line tool and just place a little segment there. That way I can snap to the midpoint. And then I will grab that until I snap to the midpoint of the rectangle. And then from there, I can double click to jump inside of this tread board there. And then I can double click into that tread board there and snap to the back there. So now it's kind of more centered, but however you want to do it is totally fine. All right, are you with me so far? So we've got all the treads and all the risers modeled. The last thing we need to do is actually model the stringers. Now, usually that's like the really hard part, but because we did this work up front, it's actually really easy because you're basically just tracing it out. So let's go ahead and jump outside of that component. And what we're gonna do is just draw. We're gonna grab the rectangle tool with the letter R, and I'm just gonna reference this surface here so I don't have to lock an axis. And I'm just gonna start a rectangle. Now, typically you'll use a 2x12 pressure treated board to cut your stringers out of. So I'm gonna type in 11 1/4, so 11.25 comma 1.5 inches. So 1.5, enter. And then I'm gonna use the push-pull tool to extrude that out. The length doesn't really matter because we're gonna cut it. So I'm just gonna go 6 feet. That's probably way too much. So whatever, I'll go 5 feet. And now you wanna turn that into a group. So actually you can use a component in this case because you will be, making multiple copies of it. So triple click, right click, make component. You can rename that to be stringer. And then what you need to do is just bring it down into position. So by tapping M for the move tool, and if you tap the up arrow to lock the height, so a lot of times it's easier to break down movements one axis at a time. So you move the height first, then you move the green axis with the left arrow key, and you kind of just break it down one at a time. Don't try to move it all at once. It's a lot easier that way. So actually we want the stringer to be up against our risers as well. So let me adjust that. So I'm gonna tap the left arrow key to lock the green axis, and then I'll come over here and snap to the riser, and now we get a nice intersection of the riser. So we don't even need the reference grids anymore. So I can go over to my layer and turn that off. And then we just need to rotate the stringer into position so we can start to trace out the cuts that need to be made in the stringer. So with the rotate tool, which funny enough, it is letter Q for the keyboard shortcut. So we want to actually pivot from this corner because we want to align it to this corner. We want to align the board. Here, let me hide this floor real quick so I'm not jumping into the floor. So we want the stringer to be aligned to these points here. So we're gonna grab the rotate tool and I'm gonna click once. Then the second click is going to be your reference edge that you wanna rotate. And then you can do your third click right at this intersection. So now you have it perfectly aligned along those stair treads and risers. And then it's just a matter of double clicking with the select tool and then tapping L for the line tool and tracing this outline. So I'll start over here. I will snap to these corners, and sometimes it'll stop the line tool because like I created a new face here because it's like a perfect triangle. So it like escapes from the line tool. So you just have to activate the line tool again. And if you're wondering how I toggled this view where I turned off the rest of the geometry, I actually have a keyboard shortcut set up that toggles this setting right here. So under the view menu, component edit, hide rest of model, I set up the letter X to toggle that for me because I use that quite a bit. I will try to remember to link to an article that shows how to set that up for you in the description. All right, so let's go ahead and finish this off. So click once, click there, click there. And you can snap to a perpendicular inference when you see this purple or pink line here. So when you see that, just hold down shift and that'll lock that projection. And then you can snap to this edge and it'll bring that projection intersecting with that edge. And then the last one we need is right here. So I will click there. We will try to find that intersection. We should have an intersection there. There we go. And then same thing, I have that perpendicular inference and then I'll snap there and we should now have our stringer shape. So you could use the push-pull tool to extrude all of these here. So just the letter P, and then once you've extruded one to get rid of it, you just double click on the other ones to get rid of them. And there you go. So now you have a stringer. So I hope you have found this video helpful. Obviously from here, you would copy the stringers however many times you need and finish off your stair design. But I just find this method of creating the reference geometry first and having that reference geometry represent the finished dimensions of the stairs and then working backwards from there, it just like completely eliminates any chance of human error, which believe me, I've made many mistakes designing stairs and building stairs for decks and inside houses and stuff like that. So I find this method to be really helpful. I hope you find it helpful as well. Thanks for watching this video. Please remember to like and subscribe if you found this video helpful, and I will see you in the next video.